So then we move this up here and then Control C and then Control V and move the new one down here. Then we connect the threads using the items and the XYZ. Then we hit run and we get a message over here. Now the reason for this message is because, as we remember, we said all of the values should be read as strings. So the numbers that you see over here are actually threads of the text, not actual mathematical numbers. They're like, for example, A and B. So we go over here and right click and look for toNumber, and this program actually turns the strings to numbers. So we'll create two more of it and then connect them to the lists and the indexes. And then by the other side, we connect them to the point by coordinates. All right, and then we'll select them and then right click, align selection and put them on left. All right, then select them and then Control C, Control V to create three new ones and then connect them to the indexes that we have on the bottom. And then by the other side to the point by coordinates. And then we hit run. All right, now let's see what we have here in the index that we have. It says 3.5. All right, now let's go over here to see why the error happens. So I solved the issue like this, and it was actually because of the value and the numbers that we had actually given to the program ourselves, and it couldn't create numbers from them. But now because of the adjustments, we can get the points that we wanted like this. But what do we want to do now is erase the 0 that we have in the list. Instead of the 0, we wanted to have the 3.5. So I'll right click and search for plus, then create a code block and write in 3.5 in it, and then connect the plus to the strings and the coordinates. Then I'll connect the plus to the coordinates on the bottom as well. Or excuse me, we erased that, but we'll create a new code block and a new plus, and then connect them to the threads. Hit run, and there we go. So now that we've gotten the points, we can create a line by start point, end point, and connect it to the point by coordinates by the start points option, and then by the end point to the other coordinates, and then hit run. Now we've simulated the exact type of design that we had in the AutoCAD file right over here in the Dynamo. But now we want to turn the lines into pipes. So I'll save it up to this point and create a new folder in the files and name it Dynamo. All right, so open up the folder and we'll save the file right here under the name of Convert Excel to Pipe. All right, and then after we're done typing that, we can hit save and get back to the Dynamo. So right here, we can right click and look for element types. And then after we've opened up the app, we can look through the menu that we have and find pipe type. Now let's see where we can find that. It's right here. And then after that, we can right click again, but this time look for all elements of type. We open that up and then collect it to element types. Hit run, and there we go. We can get a list of all of the element types that we have in the project. Now we don't actually know what the name of the elements are, so we can go over here and right click and look for element name. And then we connect that to our thread like this, and then we get the names of the elements as well. So now through the list, you can see the number 4 that we need is PVC sanitary. So I'll right click and open up the get item at index, and then I'll add a watch next to it as well and connect it to the element's name and the string. Now the watch shows the list itself and we don't have to maximize it. Now we'll connect the index to the thread and add a code block to it and type in 4 in the code block. So now we have the types of the pipes, but we want to see in what kind of system, either it is sewage or vents or hot or cold water, or where else we're going to put the pipes in. So now I'll select all of this new thread, and then hit Ctrl C, Ctrl V to get a copy of it. But this time, go through the thread and find the first block that says element types. And instead of the pipe type, we go through the menu and find the piping system and select that one instead. Piping system type. Then hit run. And now we can see through the watch where the sanitary goes, it's in the second system. So I'll change the number of the code block to 2. And there we go. So now in the search bar in the library up here, I'll search for pipe by line. So we have a package here that says ME Power, which you can search for online and download it. And it's actually one of the most used packages in the Dynamo. So I'll open it up and put it over here. And the first input that it has is the line. So what is line actually in the thread? It's the last output that we get from the thread, so we connect it. After that, we have the pipe type. It starts from this part of the thread, and the output is item. So we connect the item to the pipe by lines box. And then, as you know, the system type is the pipe type that we have down here. The next category is level, so we'll search for level by right-clicking, and let's see which one it is. It's the 4100 level. So select that level and then connect the box to the pipe by lines. After that, we have the diameter of the pipe that we're going to be using. Now we can assume that all of our pipes are going to be the same size. So if I actually go to the AutoCAD file and close this, you can see what I'm talking about. We go over to the mechanical plans. I should also tell you the point that you can actually look at the detailing of the plan and find the equivalent diameter there. So here it says this is the diameter that we use if you had a push fit, and this is the one where we have the polyethylene. Now it can be different for different companies as well. Some of them use numbers like this, the 63, 75, 110. Some use the equivalent that is 50, 70, 100 and else. And so you have to manage this based on the contractor and the company that you're working with. So for now, the biggest diameter that we have here is 4 inches. So we'll assume the rest of them to be 4 inches as well. And for the equivalent, I'll just put in 90. So type in 90 in the code block and then connect that to diameter. After that, I'll go to the search library and type in elbow and select the elbow package that is delivered by MEP Curves. Open it up and then connect it to the pipe by lines by one side to the pipes. Then create a code block, type in 2, and then connect it to the margin. Now the fitting isn't actually important here, we just want to check. So in the Revit file, we'll go to the 3D view, but first let's get a save of the Dynamo and then hit run. And then after that, let's see what we can get for our response, and there we go. So the error says that the lines are too short, and it's actually talking about 7 lines, which we can delete. And there won't be any problems. So I'll minimize the Dynamo, and if you actually take a look at the plan that we have in the Revit file, you can see what we're talking about. Let's go over to the East view. Here I'll put this on fine so we can get a better look at it. And you can see how the pipes have been planned and drawn in the plan right here. So I'll open up this level right here, and then on the details that pop up in the graphics section, I'll click on the parts visibility option and open up the visibility graphics menu. Now I'll go over to the filters tab and delete the hydronic that we have so that there won't be any issues here. And then I'll go over to the view range, then put the offset for the bottom on -0.7 and the offset for the level on the same as well. Then apply and then put this on fine. So this is an excellent method of checking out the critical points that you have and see them in a 3D view. Now, in order for me to see this better, I can select this part of the plan and hit a section box, and we don't even have any slope yet. Alright, so when this opens up, I'll put it on fine. Now it's taking a bit of time, so we could actually hide the beams that we have in the ceiling to help the process. Otherwise, our work will be slowed down. So now I'll activate the light that we have here and unhide the section box, because in its normal setting, the section box is actually hidden in its default template. And so we'll have to select it like this, and then select the unhide category option. And then we'll just have to wait for the command to be applied and for the file to respond. So I increased the space of this area that we have. Now let's go over to the visibility graphics menu and to the Revit links tab and open up the display settings. Now in the model categories tab, we can put this on custom and open up the structural framing through the menu. Now I can uncheck all of the boxes here except for the girder. Then hit OK and apply and OK. Now this may reduce the size of the file a bit and help us. So we open up the visibility graphics menu once again and go over to the Revit links, open up the display settings, and in the model categories, I'll uncheck the generic models parameter as well and hit up. I'll put the discipline on coordination so we can see the plan in full details. Alright, then put this on shaded, and there we go. Now you can see how easily you can find the critical points in the plan and in the 3D view. Now I'll rotate the plan to get a better look at it and see exactly what we want to find. Now it makes your decision makings a lot easier about where there may be faults in the plan and there need to be revisions. Like this right here where we said the branch couldn't actually fit. Now I can actually use the trim tool to trim these two pipes together and these two as well to see what happens. Now this was okay for now, but if you actually go somewhere where the limitations might be more severe, like this part right here, and use trim to connect these, we can see where the issue shows itself. Now the two fittings don't even match to this part and they've been inserted on top of each other. So as we said, using this method, we can have a quick initial check of the issues that we have in the plan and make the revisions in the shortest amount of time possible.